Hi everyone, thought I'd make this video just because it was a common one that I saw people asking during office hours. And so this is from homework 6B, and it's problem 6. So first off, I forgot to post the figure in there. So now the figure is in there, and I apologize for having done that. But basically, the problem goes that a roller coaster car speeds downhill at a point past point A and then rolls uphill at point past point B, as shown in the figure. So here is finally the figure here. So here's point A, here's point B. I kind of set myself up for point B. I'll talk about that in just a moment. The car has a speed of 20 meters per second at point A. So down here, 20 meters per second is the speed. We know that. And then we know the normal force here is 2.06 times 10 to the 4 newtons. Okay, awesome. What is the mass of the car? So let's just start there. I'm going to ignore this part right now. So what is the mass of the car? Well, I'm going to start with drawing a free body diagram of the forces acting on the car. So if the car is down here, I'm going to have weight pulling it down. So there. And then I would also have the normal force pointing up. And like we saw in class, right, the normal force has to be bigger because it's accelerating upward because it's moving in a circular shape. Oh, and I also know that the radius is 10 meters. They give me that there. So I'm going to use now Newton's second law. I'll call this part A because there's kind of two questions being asked. So I'll call the first question part A. So it's going to be F net equals ma. F net, well, I got two forces here. The normal force points towards the center of the circle, so that's going to be the positive value. And then mg points away, so it's going to get the negative value, equals mass, and then it's a centripetal acceleration, so I can replace that with v squared over r. And then next, so isolating the mass is a little bit tricky. You could start plugging in values. That might be a little easier for you, but I'm just going to do this variably. So I'm going to add mg to both sides. It's mg. And then mg cancels out. So now I'm going to do the normal force is equal to mv squared over r plus mg. And I can see here, hey, wait a minute. That's both mass. I got mass in both of those terms, so I can actually factor out the mass. So this can be written as mv squared over r plus g. And now lastly, I'm just going to divide everything by v squared over r plus g. So I'll divide by v squared over r plus g. And then over here, I'll divide by v squared over r plus g. So I now have the normal force divided by v squared over r plus g is equal to m. So plugging everything in now, the normal force is 2.06 times 10 to the 4 divided by the speed is 20 meters per second. So that's 20 squared. 20 squared divided by r, which is 10 that I found, plus 10 is g. I'm just calling g 10. So plug this really quickly into my calculator. What do we got? 20 squared divided by 10 plus 10, so it's 50, and then we got 2.06 times 10 to the 4 divided by my answer there, and I'm getting about 412. So I'm getting a mass of about 412 kilograms. Hopefully that's right. And then for part B, now for part B it says, so finally I'm going back here to part B. So part B says, also, what is the maximum speed of the car can have at point B with a gravitational force holding for the gravitational force to hold it on the track. Basically what this is asking, it's saying the maximum speed, right? Because and I got this diagram here. If you've ever seen like any action movie, right, where like a car goes over a bump or something like that, I can go really, really, really fast, and this car is going to go flying, right? It's going to go super fast. Like, you know, over the thing. So definitely, like, there's no minimum there's no maximum speed that it can have. It can just keep going faster and faster and faster and faster, just bump over that hill. So what this question is basically asking is, what's the maximum speed this car can move so that its wheels are like still touching the ground, but if it went any faster, it would just bolt right off of this thing. That's what they're basically saying. So what's the maximum speed this thing can have so that it does that? So basically what we're saying is, if let's say I drove really slowly over this, right? If I drove really slowly over the hill, well, I could draw a free body diagram, and the forces would be, there'd be the weight pulling down, and then there would be a normal force, right? There'd be a normal force pointing up. And then the normal force would have to be less than the weight because, again, it's accelerating towards the center of the circle, and mg would have to be bigger. We did problems like that in class. So, it's basically saying that the tires, the tires are almost about ready to leave the ground. Almost about ready to leave the ground. And so if the tires are, the weight's not going to change. That's just the earth pulling on the cart, right? That's just, it ain't going to change. It's going to always stay like that. The earth is always going to be pulling on the cart. But the normal force can change depending on, because the normal force comes from contact with the ground. So if we're talking about the maximum speed the car can have, so that the gravitational force is still, is basically the only thing holding it onto the track, well, that basically means then that the normal force is equal to 0. Right? The normal force would be equal to 0. So if I was to draw this, right, or if I was to do this on a problem, so I'm going to do this in part B right over here, I'm again doing F net equals ma. And I'm going to include the normal force, but then I'm going to set the normal force equal to 0. So F net is, again, towards the center of the circle is the positive direction. We established that norm in class. So mg is going to be positive, and the normal force is going to be negative. So this is going to be mg minus the normal force equals the mass times the centripetal acceleration, right? That's centripetal acceleration, so that's going to be v squared over r. But now we're getting that the normal force is equal to 0. So normal force equal to 0 to find maximum speed. I'll call it Vmax to find the maximum speed. So now I'm left with mg equals mv squared over r. Mass cancels out. So I got g equals v squared over r. Multiply both sides by r. That's going to give me rg equals the square of v. Take the square root of both sides. And I finally get the square root of rg is equal to v, which is the square root of, the radius is 20 this time? No, 15. So the radius is 15 times g, which is 10. So it's the square root of 150. And 12.2. So there we go. Hopefully that helped. All right. See you guys. Bye.